on the example of Amazon Web Services and also talk a little bit about serverless itself. The serverless framework is a framework that enables us to develop easily and deploy application to Amazon Web Services. It's a framework written in Node.js and requires Node.js to execute. It has very good support, a lot of documentation, and a lot of active community. There are YouTube videos with some demonstrations of the examples and blog posts appearing very often. I would say a few times, if not few times a week. So what I want to talk about on this presentation is serverless. What's that? I would give you example how to realize an example multi-tier application on Amazon Web Services, which services to use. It will be an example of web application that has a static HTML page, a REST API, and storage. Then I'll show you serverless framework, how to use it to deploy serverless applications, and I'll give you some examples. Serverless, what is serverless? To better understand the fancy buzzword that we hear very often nowadays, let's look first about short history of how we got to serverless. First of all, a very long time ago, there were no cloud providers, and everyone who wanted to release an application had to buy a server, deploy drives, memory, configure networks, and if he wanted to have this application reliable, probably he would have to also set up another application server. Here's how it looked like. Then, because it was kind of difficult and costly to maintain such so many services ourselves. Some companies thought that it would be nice to release this as a service. So that appeared Infrastructure as Service, IaaS. And then we will only worry about operating system and all the middleware and runtime in case of, for example, Java applications. We're talking about Java virtual machine, and then we could deploy our applications and data on top of it. Still, it was a bit cumbersome because we had to maintain all the patches, security patches, and updates of the operating system and our application, our middleware. To keep the application safe, for example. But the virtualization servers, storage, and networking was on the hands of the provider. And then we go to the more advanced model, which is platform as a service. Platform as a service is sorry, I'm having a little bit of cold, so I will do it from time to time. So a platform as a service is there are a few approaches on how to implement platform as a service. These are containers and function as a service. I'm going to talk about function as a service today, but containers is another way of realizing serverless application. Is where we build an image, a Docker image, and we can deploy it into the services provided by a cloud provider, and we don't worry where those containers will be started. We only worry about creating images so that the application can run inside the container when the container starts. And when the container dies, there are features provided by cloud provider. For example, we can easily scale it. We can describe how many minimum of number of containers should be running all the time, and if one of dies, a new container will be started by a cloud provider, our provider. In case of Amazon, we have ECS, Elastic Container Services, where this can be implemented, but it's not the subject. And today I'm going to focus on function as a service. Function as a service is where we need to implement a function. The function we code in the desired language, and it needs to follow certain requirements. For example, in case of Java, it's a class which has a method coming from a certain interface. I'm going to show you later how it looks like. So first, what are the pros of such approach to cloud applications? First of all, don't have to, like I said, worry about hardware. We don't have to install security patches and manage the infrastructure because it's done by our provider. Then, because we are constrained by the services that we need to use, we need to follow the particular approach to implementing services. These are services which are loosely coupled, and that way they are following good programming and design and architecture design concepts. These are not big monolith with a spaghetti of interconnections between modules, but these are small pieces that are independent from each other, because these infrastructure services are also distributed and independent from each other. And another point, it scales easily. That means that if we need to put more services, for example, if our application is growing and we are getting more and more customers, and we need to support more traffic, we can start new instances of our functions, and they will handle the traffic, and we don't have to worry about buying necessary equipment in advance, because we can do it in any time. Also, if we have like peaks, daily peaks of usage, we can describe how many containers should be running minimum and maximum, so that it can automatically grow. The number of services can grow and handle necessary traffic. Because we are paying for what we use, it's kind of cheap. But there are also disadvantages of that. First of all, we are stick to particular provider. If we choose to use Amazon Web Services, it's very difficult to migrate to Google or Microsoft Cloud, but still possible, and probably easier than if we had our on-premise application installed on application server. That would be a big monolith, and to deploy it to cloud, we'll have to split it into more granular pieces. And then a next drawback is that when we create application, we need to think already about which services we are going to use. It's not like we first create the application and then think how we're going to install it and where, but we need to know it up front. It's a disadvantage and advantage itself. Like I said, it's a constraint put on us that we need to develop our modules so that they are small and they're independent. Finally, this needs a little bit of learning. We cannot choose off the middleware that we already know. We need to use particular middleware, and it has its own limitations. So how can we implement a basic multi-tier application that has a UI, it has an API, REST API, it has some logic in service layer and persistence on Amazon Web Services? First of all, the static HTML page with CSS and JavaScript we can put on S3 service. It's a simple storage service. Then in it we can invoke APIs, REST APIs, which will be supported by API Gateway. API Gateway is a service where we can configure API paths and methods this API will have, and then to those paths and methods we can attach different functions. And functions are the core of our application, where the business logic is, and those functions are running in Lambda service. And Lambda service can be triggered by different events. I will say more in next slides about characteristics of Lambda service, but mainly today I'm going to talk about Lambda and API Gateway because those are like core components of the example application. And finally, there is a storage. The storage can be DynamoDB, and it's very likely to be DynamoDB with Lambda, because in case we wanted to use a relational database, like on Amazon, we can use RDS service. We put it inside accessible from we need to install Lambda inside VPC. Fortunately, it supports it already, but in the first days of the Lambda, it was impossible. But anyway, it requires more configuration. So the simplest way is to use DynamoDB, which is NoSQL key value store. What is API Gateway? Like I said, it allows configuration of different HTTP methods, and it supports caching of responses, and it supports also distribution of the API in content delivery network in different geographical locations. So that, for example, if I'm a customer, if I am a client of this API and I am located in Poland, I don't have to connect to USA location so the request response time is shorter. I can connect, for example, to London region, and that way it guarantees a stable performance across the globe. Then there we have a built-in security. We have support for cross-origin request sharing by headers. Thanks to that, we can install our custom our static HTML page on S3 and configure course so that only domain where the static HTML page is located is being served by our API and not all the other domains in the world. We have also AIM service support, so we can integrate authentication and authorization to our API with identity and access management service on Amazon. For example, we can put users to Cognito service, and then the request will be signed with AWS signature v4 algorithm, and the information in header will allow API Gateway to recognize which user is authenticated. And then we can also generate client SDK from API. I didn't use it myself, but it's documented that it's possible, and the cost is low. An example cost taken from Amazon examples is when we have an API that has 5 million calls per month. Is a service where the heart of our application is. This is a function which we write and deploy to Lambda, which is triggered by events. One of the events is from API Gateway, but we can run Lambda on different events. For example, from Amazon Queues, from Rational Database, from Dynamo, many kinds of events that can be triggered, that can trigger Lambda. It also supports caching. We can use caching in Lambda. We can use, as I said, we can now deploy it in virtual private cloud and connect to rational database into RDS service, and we don't have to store password and user inside our application, because we can also use KMS service, key management service, where the password and user are encrypted, and we just get them out of there using tokens. And then Lambda is protected. We can restrict access to Lambda as well as a API gateway by Amazon policies and roles for the users created in AWS. And I said that we don't have to think about in which operating system and where the Lambda function is running, but we have this possibility if we need, for example, support of some native libraries that are not present there on the runtime. We can create our own, we can craft our own Linux image from Amazon Linux image, which is normally used to run Lambda on, and install that and link it to our Lambda, configure it so that our own image will be started when the function runs. Example of Lambda cost taken from Amazon documentation also is when we have a Lambda configured to use 512 megabytes of memory and is executed 3 million times on the month, in the month, and each execution takes 1 second. So here we pay for the length of the execution and a number of executions, and also we pay for how much memory Lambda is supposed to use. We can configure the memory used by Lambda, and then it is the time of the usage multiplies the number of memory, and it counts in gigabyte seconds per month. What is important, 400 gigabyte seconds per month we get for free, thanks to Amazon free tier, and that means it's not only for new users, but all users have 400,000 gigabyte seconds free per month. It's kind of a lot. If, for example, we are doing a startup, we need an environment to run this for testing purpose or for demo. It's a good candidate to decrease the cost. Lambda supports different runtimes. We have now Node.js, Java, Python, .NET, and since a few days also Golang. And unfortunately, there are also limitations. For example, these languages that I said that we cannot use different. We are bounded by container initialization mechanism. If the Lambda is run for the first time, that means that container, the virtual machine, needs to be started before the Lambda can execute, and sometimes the time is so long that it's unacceptable. Normally it takes, with 500 megabytes memory, a container takes about 1 to 3 seconds to start for Java applications. This can of course be longer if you use a custom container. And then another thing is that the Lambda function runs only as long as the application can run on Lambda as long as the function is running. For example, if we wanted to deploy an application which has background threads, and we would like those threads to be running through lifetime of the container, it's impossible, because after our function exits, all those background threads will be frozen, and they will be refreshed. They will start executing when the next request is handled by the function. So, for example, if we deploy a Spring application Lambda, we cannot use. It's very often used um, Quartz jobs, because they will not be running when the request is not coming and when Lambda is not executed. We have some restrictions regarding the disk storage. It's 512 megabytes. Also some restriction regarding number of processes and threads, which we can start in file descriptors as we see here, and the memory from 128 to 3000 megabytes. Also, the request response size cannot exceed more than 6 megabytes in its synchronous call. In case of API gateway, it's synchronous call, and 128 for async calls. I won't tell now about different architecture patterns because it's a talk for different presentation, but we can implement different topologies in AWS. What is Serverless Framework? Serverless Framework is a set framework written in JavaScript, in Node.js, and we need to install Node.js before we can use it. It's very easy. We can just download the zip and extract it and add binaries to class path. And then we need to install serverless module globally, and then we can already use it. But before we deploy our application on Amazon, we need to configure credentials, and it's done like normally for Amazon command line interface. We need to configure the credentials. It's done in file in the user home AWS credentials. For example, here I have two profiles. I have default profiles with these credentials, and I have SLS profile, which I'm gonna use, which has access to CloudFormation service, and this service is used by serverless to manage the stack, the stack of resources that will be created. We can first check which commands are available using and then we have SLS create. SLS create takes these parameters. It takes template. Template is one of many. We can use templates for application in Node.js, in Java, in Python, with different build system, with Maven, with Gradle, and for different cloud providers, for Amazon, Azure, and so on. So let's create an example application with template called AWS Java Maven, and we're gonna put it in path in the folder called demo, and that will be also the name of the service which will be created. This command created the following file structure on disk. There is a POM XML which will be used to build our application, and serverless YAML, which is configuration of our stack. And let's see what's there inside. So the POM has already a few dependencies in it. Those are Amazon libraries for Lambda, for Lambda, and for Log4j configuration on Lambda, and faster XML Jackson for serializing JSON to objects and reverse. And it has generated which is there, which is called called hello and a handler. The handler is a Java class which has a method which is invoked when the Lambda is running. So it looks like that. It implements a request handler from Amazon library. It can also implement the different interface. I'm gonna talk about in a second. But then we have a handle method and the request method, which takes an input and method returns an output type. And what it is at the moment, it takes a map and responses API gateway response. So it's like an object which is prepared for handling API gateway responses. But here we have only Lambda. We don't have any API gateway yet configured. So how to run this application? First of all, we have configured here the jar which will need to be first built to run the application. So if we try to run it without the build, it will fail. But what SLS allows us is to test this application local. So there is SLS invoke local, where we can choose function to use. This in the case it's hello, function name hello, and we can choose data to be used. With data is JSON that will be serialized to map by Lambda and by Serverless Framework. It will run it locally, and then we can put JSON like hello, oh, and it will fail because it was not built. So we need to do maybe a clean package first. Okay, so it failed also because I forgot that I have turned on particular settings, security settings, maybe. So I'm gonna remove it, and now it should work. And now we can run it locally, and it will respond, and it will also log. It will log the map, as we see in the code in the handler. There is a log received, but the response is in that form because we don't have a toString toString method implemented. But if we deploy it to Lambda, it will show the text from Lambda, which will be JSON. So how to deploy? We have a SLS deploy command. We can take -v, which will add verbose logging. So we try to deploy, it will fail. Why? Because I do not have access for my default Amazon profile to deploy, to create stack for to create cloud formation stack. I need to use different profile which we define this way. It's less. And now I can deploy, and we will see what it's doing. But before we do it, I want to show you one thing. Serverless created a folder called .serverless when it is deploying to Amazon. In this folder, we have two files. We have CloudFormation template create stack and CloudFormation template update stack. These are CloudFormation templates which we could write ourselves and use native CloudFormation capabilities to create a stack, but Serverless Framework is doing that for us, and the configuration that we provided in Serverless YAML is translated to these templates. And the first template is used to create a basic stack with only S3 bucket into which the jar of our application will be uploaded, and then when it's uploaded, it updates the stack with a new template, and this template already creates all the resources that we have configured in our serverless YAMLs. For example, it contains Lambda function that we defined and all the necessary privileges for this Lambda. For example, policy to allow logging to log group for this Lambda. And so far there's not much here because we don't have many resources defined in serverless YAML. So let's see what will happen. We will see some logs from deploy. First, our stack, our basic stack with S3 packet is created where the jar will be uploaded. And these logs we can also look at from the Amazon console. If we go to cloud formation, you can see that the new stack is being created. The name of the stack is the name of the service, and appended name of the stage. The stage is like an environment, describing an environment. You can have different stages for different environments, for testing, for production, for development, and all the resources will be added this this postfix for the name of the environment. So there we can see which resources were created. So we have log group and we have packet, and we have a Lambda, which is being still created, and we have the same logs that serverless is showing here. And at the end, serverless will print a message showing what the stack looks like. We can get similar message with SLS info. And now we can invoke our function already, not locally, but we can invoke it on server. We still don't have any API yet. It's just the function that we are manually triggering using Amazon SDK, Amazon command line tools, and it responded with a message that we expected, that is hard coded in our handler here. So if we change this message and want to deploy it, let's say new message and input, we don't have to deploy the whole stack again. We don't have to SLS deploy. We can deploy a single function, and then it's much quicker because it only, okay, now it did nothing because it calculated the checksum of the jar, and so it's the same as before because I have not built it. So Maven clean package would change the jar, and then we can deploy it again, and it will be really deployed. And it takes like 2 megabytes of size, and this jar is deployed, and we can run it again and see that the response has changed. Here. We have the message expected new, and serverless also give us way to manage the versions, so we can see which versions of the function and which version of the stack are deployed. Let's say we want the back version of that function. We can type SLS deploy list functions. And we see that we have latest version and version 5 because I already experimented before and I used the same name for stack. So it looks like the number of version is counted from the last version used in the destroyed stack. And if I want to roll back this to the previous version of Lambda, I can type SLS rollback function, and this takes two arguments, function name and version, hello, and version 5, and I can execute it once again to see that it rolled back the function to the previous version, because the message will be S. Let's roll back now so I can execute it once again. And we see the message as before. That feature is very useful in case we have a continuous integration, and let's say we deploy the version and we are running tests which do not pass, and we want to roll back this version to the previous one. We can implement automatic rollback in our build server. So I have another example where I have two different handlers written that use different interfaces. I said before that we can use this interface called request handler to implement our function, but there's another interface also called request stream handler. And what's the difference? The difference is that the first one requires to have plain old Java objects in the input, otherwise it will not work. And the next one, we need to deserialize ourselves. So we need object mapper, Jackson object mapper, and we can serialize input stream into the request objects that we are expecting, and the same we need to serialize an object, a response object, to the output stream. So if we look at the example here, I have a request DTO which is not a plain Java object because it has no default constructor and it doesn't have setters and only one getter. So this was created for the purpose of validating the JSON that comes to the Lambda with Jackson. I am expecting a key in JSON, an M key, which should be serialized to the message field in this object, and it's required. So in case 1, if I run this function, SLS invoke, this is already deployed, I already deployed it before. I have function test 1, and I want to run it with data, JSON data like before. Let's put M, which I am expecting to be valid, and and the response is empty. Why is the response empty and it did not fail? Okay, I think I will redeploy it. Will be Maven clean package and SLS boy minus F this test 1. Because I think I have deployed a different version when I was testing, and it's not that one. So if I invoke it again, it has failed like expected, and it says that no suitable constructor was found. So if I do it with the second function, the same request go, it will work and it will successfully serialize. Oops, not really. Okay. Okay. So let's also deploy function 2, but that's not what I was expecting. Yeah, so that works. So that means that this JSON was deserialized, and the object request DTO was created, and then in our test2 handler we are getting the message from it, and we are sending it as a response. And the response DTO has key name data, so that's why we get this response. So if we change function, oh, we can test one more thing. We can test that the validator really works. If I put different key than expected, and it will fail with the Jackson error that expected key is not found. Yeah, it says missing required creator property. Yeah. So now if I change the request DTO to be a plain old Java object way, and we add getters and setters. And I will redeploy it. On. It should correctly handle the request as long as I will provide JSON with the key message, because it is not using Jackson this time. So it's based on the getters and setters. Yes. Let's turn back to the original example and deploy it. And then I have more examples. I have an example of cron job. It takes no input and returns no output. You can do it this way, and it's just logging the time when it's executing, and is defined in serverless configuration this way. We can add an event to the function, which is based on the scheduler, and the minimum frequency that we can define is 1 minute. Lambda doesn't allow on more frequent execution. we can easily get logs for any function in serverless framework using SLS logs minus f and the function name. So our cron job is method is called cron. I can get them like that, and we see it's executed every every minute. And then next example, how we can create an API a gateway using serverless, so that we can have a REST API. We can do it this way. We can attach an event of HTTP into the function. I have here an echo handler for the function that can be triggered from API gateway with the path echo. So it looks this way. It is just taking an input from API gateway, and this object, this DTO, is a specific DTO because it depends on the JSON format that comes from API gateway. In these examples that I showed before, I was passing any JSON to Lambda function, but if the message goes through API gateway, the JSON contains different properties like headers, resources. So we need a specific DTO, and thanks to Amazon, this is already implemented. We can add the dependency in POM. It is called AWS Lambda Java events, and we have these objects already, and we can deserialize and serialize them in our handler, like I do it here. So if I post a JSON like that, it would respond. Okay, this is not the URL because I redeployed this example, so I need to take the good one from here. So you see, when I created the new stack, the URL has changed. And it responds with the message which has, let's have a look at the response from that. It's API gateway proxy response event, and what I'm putting there, if it's a post, I'm putting there oops. This is not the version which is deployed of that function. This is the version. It takes a map and it uses this API gateway response that is provided by default from serverless, and it's sending echo and the input. So the input is really in the form of the JSON that comes from API gateway with all the information. Next example, I wanted to show you that there's a library that allows us to deploy Spring application to Lambda and use API gateway. It's there's an example. The library used is AWS Serverless Java Container, and we have different implementations. We have implementation for Jersey, Spring, and Spark is a lightweight framework for Kotlin REST services. So these libraries provide us a class which we can use in our handler, which is called Spring Boot Lambda Container Handler, and this is creating a proxy for all the requests, so that the Spring container can be initialized and handle all the requests. What is important in the serverless configuration? We need to use the path of this type proxy. That means that any path that we will invoke the handler, the API with, because the API is like that. Any path that follows that will be proxied by the Spring container. So, for example, in our example application, we have a pets controller, and it has a get method with the path pet. So, if I copy it and type in the browser, see that it's while because it's the time when the Lambda container starts, and afterwards the container will be already initialized and it will be quicker. So we can look at the logs. Yeah, it returns some data. We can look at the logs. The function name is petstore function, and we can trace them so that we get all the logs as quickly as they appear. There is some delay, but we see that here that the Spring container was initialized. But now, if I invoke that request again, it will not show all these logs, and the response is pretty quick. It will only show some logs like null, because there's somewhere in the controller it's printing null. So we see these null, but not whole initialization. And when we do not have any traffic for a while and the Lambda container dies, it will again have to start and we will have to initialize it again. So we need to count with that. And what is really power of serverless framework are plugins. And here I have an example application which is using two plugins. It's a example REST service that allows creating to-dos. It is using two plugins, Serverless DynamoDB local and Serverless offline. And these two plugins allow us to run the serverless application locally without deploying to Amazon. We can just install the required plugins and we can start the application. I will show you. So now we just need to do this and we can start the application in offline mode, and it will run also the DynamoDB local. DynamoDB local is a Java application developed by Amazon. We just need to download one jar, and Serverless is doing this for us and start it on port, and then the application is connecting. So, for example, if we look at the Dynamo service configuration, it has a environment parameter. If offline is used, it's connecting to local DynamoDB. And now we have REST API with DynamoDB running locally. No need to have internet access, and we can visit this URL, and it will show available endpoint. But if you go to the endpoint, like to-dos, should show the list of to-dos, but we don't have any to-do yet. We can quickly create one. There is a URL command for that. If we run it, we see that we already have one to-do. So it runs completely on the local host. And when we deploy it, we can check it that it runs same, but I'm not going to show you that now. Okay, one more example. The last example that I wanted to show you is a plugin which allows to deploy the static page to S3 straight from Serverless Framework. And I have here an example application with static UI, which is React application. It's placed in the client folder. When we build it, it's minified, and all the static resources created in the build folder. So I can use a plugin for that. Plugin is called Serverless Finch, but it's not important. What is important, I define the packet name where I want my website to be in, and I want the local folder where the static resources are. And if I type SLS client deploy, it will deploy it. I will only show you that I have already this deployed. If I go to S3 and find the packet, this one, and go to properties, there is a URL to this website, and now it looks like that because it's not yet finished, but you can see that it's served publicly. So for demo purposes, it's very nice. used by Serverless Framework, but we can write them CloudFormation template ourselves, like I shown you at the beginning that serverless is translating. There is also serverless application model, which is not so recently, but it was developed by Amazon. It's very similar to similar configuration file, but this does not have the support for plugins yet. Maybe Amazon is thinking about that, but it's not the current case. So this is the advantage of Serverless Framework. But the real advantage is that the community is very powerful. There are many blog posts and the examples on GitHub are great. By the way, even the page itself is open source and it's available on GitHub, and we can see how it's configured with serverless and examples. Most of them is for Node.js, but we have only one probably for Java, but we have different examples on different platforms, and not only Amazon, and we can figure out probably how to do it in Java if we want. So that's it. About framework, Serverless Framework, and cloud on Amazon Web Services. Thank you.